Welcome to the Cube Skills community, coming at you live here on YouTube on July 18th. If you're in the chat, say hello. Tell us where you're tuning in from today. I'd love to hear from you. So Cube Skills is a community for everyone to join and collaborate with others to learn containers and Kubernetes. And today we're joined by Thor Sigurdsson. Thor is a co-founder of Garden.io. And Garden, for those who are unfamiliar, is a development automation platform for Kubernetes. So excited to dig into the state of developer tooling. So Thor, thanks for joining us today.
Thanks for having me. Yeah, I mean, it's there's a lot of interesting stuff going on in the space, but I thought maybe I'd start by kind of telling you about a little bit who I am, how I got into this dev tooling space to begin with, and I guess what we've learned along the way, because we've seen all kinds of things automation-wise with all kinds of sizes of companies, and I think most engineers who maybe write a CI pipeline here or there or bundle some kind of internal developer tool, you usually don't work with a lot of different kinds of companies. You're kind of familiar with the constraints and the sort of priorities of your own org. So maybe that will be interesting to the folks out there. I'm from Iceland originally. I went to uni back there and sort of started a company straight out of uni. Taught myself web programming using Rails, which it does hide a lot of the complexity from you. But the nice thing about it is I was the only technical founder, and it comes built in with hot reloading, generating database migrations, like a console for seeing what's going on in your database. You just start Rails, you start working on your app, and it's super productive. And I was learning all of this stuff, but at no point, but my development environment sort of always kept up with me, and that was kind of one of the things that kind of hooked me as well early on programming. Is you just sit down, you read some docs, you start banging out some stuff, and there was this cartoon on TV when I was a kid. I think it was an Italian cartoon, and it was about this boy with a magic chalkboard, and he would draw birds and things on the chalkboard, and then they would kind of fly off and take life. That's kind of what programming feels like at its best. You just you write down these abstract machines, and they just kind of come to life. And when your environment sort of keeps up with you, you get into this kind of magical flow state where you're just it's like a video game in front of you. So yeah, that was a lot of fun. And I sort of tried to avoid the operational side of things as long as I possibly could. We were laid into Docker and all that stuff. And then Jon comes to me with this idea for Garden, because we were both living in Berlin at the time. And he had been working as VP of engineering at this kind of largest startup here, sort of moving them off Heroku to Kubernetes. And he had just kind of run into this problem that how do I keep my engineers productive while we go to Kubernetes? They had been using Docker Compose before that, and there was really almost nothing out there, and people were struggling with really slow CI pipelines. There was basically nothing available off the shelf. This was 2018, of course. There's a lot more available now, but what his developers were experiencing was kind of the polar opposite of, at least how he described it to me, the polar opposite of what got me hooked on programming, the magical experience of having it kind of keep up with the speed of your thought. It's I don't know, have you ever seen the movie Metropolis, the 1920s Fritz Lang movie? There's there are these workers, and they're working in this kind of subterranean dystopian futurist factory, and they're sort of turning the arms on a clock, and it's kind of this bizarre meaningless machine that they have to sort of hand crank on their long shifts. And that's kind of what it seems to me just cranking pipelines all day, waiting for pipelines. You can never really sort of get that feedback unless I don't know, send it into committee. And just more and more, it's getting harder to reproduce that kind of developer experience with complicated systems that have a lot of components. And back in the days, what you're running on your laptop, you have a database and you have your application, is pretty similar to what's going on in production. In production, you have a Linux server, you have an application server, and then you have Postgres or MySQL somewhere, maybe a cache. That's it. You can sort of just start it on your laptop. There's not that much need for tooling. And by the way, stop me. I'm just kind of sort of laying the cards on the table a little bit here. But
That's good.
But back then, like one of the reasons why things felt nice back then is if you're using Python, you're using the Python tools. Library loading, migration generation, all that jazz. Your editor understands your programming language, and like everything is kind of part of the programming language ecosystem. But now that we're sort of moved into this kind of multi-container world where things are deployed on Kubernetes and you have a lot of different components talking to each other over a network, there isn't like a single tool or framework or anything that sort of ties it all together and gives you a cohesive experience. It's just like it's just like a bunch of small city-states in Italy in the Renaissance, and like everybody's got their own sort of system going. And it's really hard to like, how do you even start it? How do you even start a system with like 15 services on your laptop? And like, if something breaks in CI, how do you go about reproing that locally? It's not simple. So the TLDR of it is like, we set out to make development as fun as it used to be before we broke things up, and to sort of, I guess, reintroduce cohesion into the developer process. But like, and then along the way, we could have, learned a bunch more stuff. But I kind of strongly feel that we've sort of come to accept, I don't know, like, I see how we ended up doing things the way we're doing, where we rely really heavily on pipelines and test things, because like the pipelines right now are sort of like usually the only place where you have a repeatable definition of how your system is built and deployed. That's kind of the only place where it lives. But like, there was this post on Hacker News today, like the problem with slow tools, and there was this guy saying like, there's a huge difference between waiting for like a minute and waiting for a second. And like most people drift off in like 5 or 10 seconds. I don't know about you, Chad, but like, I don't know, what would you say is like, how many seconds of waiting does it take for you to begin like starting to space out or like looking for something else to do? Like, I don't know, where's your drift threshold, do you think?
Yeah, probably about 5 seconds.
Yeah.
If that, if I could be that patient.
Yeah, exactly. And like, the difference between 5 minutes and 5 seconds is like way more than 4 minutes and 55 seconds. It's like, we're just humans, and you can fall out of flow so easily. And, I think it's just like, it's nobody's fault. People are kind of doing the best they can with the tools that, like, I guess we're writing pipelines. That's what people do, but I don't know. We're trying to, I don't want to spend too much time pitching Garden quite yet, but it's just like, seeing a lot of companies like, so like Kubernetes, like, it's kind of, it feels to me like a tool that's built for SREs by SREs. It's a great system, but like, it's a little bit like a kitchen without a restaurant in the building. You design it like, the restaurant is a place where we serve food to customers and they come in there and they pay. But where are you cooking it? Where are you cooking it? And you end up having like this kind of makeshift kind of food cart outside, and then you carry the plates up the stairs and they're sort of cold by the time they get there. That's kind of like, there isn't like a built-in developer experience. Like there used to be with Docker. Docker Compose was shipped by Docker. So that's why I think, a lot of people, DevOps engineers and tooling vendors are kind of scrambling to sort of see like, how do we, I don't know, how do we stay sane with this new setup? I mean, it's really powerful, but like, the instruction manual does not include how do you develop and test on this thing.
Yeah. Like, batteries required, but not included sort of thing.
Exactly. Yeah.
I love that analogy about the restaurant though. I feel I work with a lot of customers, and almost every single customer that I work with has a unique setup. And it would be nice if it was streamlined in a lot of cases to kind of include that kitchen to follow that same analogy.
Yeah.
I want to set the stage for people listening who are maybe I love with what you just described about the problems that you faced and how you aim to solve those problems. But let's take a step back for a second and set the stage for and talk about the difference between the inner loop and outer loop development process. Yeah. So you're talking a lot about the inner loop. So if you could describe what that is and the differences between inner and outer.
Right. Yeah. So this is, of course, like a kind of a pun from programming land, where, like, if you have like a for loop inside of a for loop inside of a for loop, anything that happens in the inner loop has to be really tight. But like what we mean by the inner loop is like basically the stuff that you're doing, what you would call local dev. You have your editor open, you have maybe your terminal, you're recompiling, maybe running unit tests, like things are happening like on the scale of seconds, and it's like it's you could think of the inner loop usually as everything that happens up to the point where you open your pull request, and so and usually today that means like most commonly you maybe do local development on the service that you're developing. You maybe have a shared backend, maybe you're using your staging environment for some of the other stuff, and then you have like a really fast, snappy, like maybe you're using Webpack to do your front-end development, or you're just like using the Python or Ruby or Go tools or whatever to write your service. And you're in this really nice, shiny, integrated experience that's made by people who are using your programming language. And it's like, it all makes sense together. And then, but there's like, you can't do everything there. Let's say you're working on something that's like, you're working on some API, and the API is pinging some other thing. How do you know that like your changes to the API, like, let's say you're like, I don't know, making an e-commerce system, and your order service is posting to the billing service, and the billing service, does something. How do you know that your changes to the order service aren't breaking the billing service? Well, that only sort of usually comes up in CI, because like, so when everything is running on, back in the day when it was a monolith, like everything happens inside the monolith and between the monolith and the database. So that's kind of like you can reproduce the full behavior of the system with just that. Whereas like now you're usually, you're sort of you can only reproduce the things that you can run on your laptop in the inner loop, and anything beyond that's kind of happens in CI. So that would I guess be the outer loop, which is like CI automation and then the CD automation after that. But like, so I guess part of this is that like we've, I suppose, as an industry, started to accept that we're not going to just be able to do a bunch of things before CI. We're going to just like rerun the CI pipeline a lot. And I think like, it feels to me like back in the day, like CI was like a thing that you had to make sure you didn't forget to run your tests. But you would be like running your integration tests and stuff on your laptop, or end-to-end tests and stuff. But the end-to-end tests, like you could run them locally as well, usually. Which was like a lot simpler to accomplish when you only had like a component or two. You open a terminal window, you start, Python, another terminal window, you start Postgres, and that's all you need. But yeah, so, but again, and like, and even writing CI pipelines is it's not simple. They end up being, so for large systems, when you have a lot of components, like, you clone the repo, you check, does a Docker build exist for this image? If it does, then we skip this step. And there's other step, you also check if there's Docker build. There's other step, you check if there's Docker build. And then once that Docker build is done, you can deploy the service. After you deploy the service, you wait for these other services, and then you can run end-to-end tests. And then it's like this whole handwritten flowchart in YAML. And and like, as you're writing that thing as a DevOps engineer, like, how do you debug that? If you're making a mistake in your YAML, you have to rerun the pipeline. So I was like, that's insane. Like, your developer experience for debugging a pipeline is to rerun the pipeline. And to be honest, like, what we've seen a lot is like, a lot of companies, like, testing is like aspirational. Like, I wish we were doing that. I wish we were doing integration tests and end-to-end tests and API tests, but it's just like, it's too costly to write the damn things. It's just like, because of the, you kind of think about the sort of the microeconomics of writing and maintaining these things and debugging them. And it's like, it's just really gnarly, and I mean, and it's not the fault of the CI systems. They're doing great stuff for what they're doing, but they are also like, they are essentially like glorified script runners with sequencing and, and some semantics built in, but like, they don't really know what Kubernetes is usually. They're general purpose tools. And I mean, like, Terraform is a great example of a great tool that, like, you have a configuration language. There's templating in there. You can call Terraform from a CD pipeline or a CI pipeline, or you can call it from your laptop. And when you're working on a Terraform stack, you can debug that stuff locally. If you have the sort of access, for that. But like the same isn't yet there for writing pipelines and maintaining pipelines, and never mind like if you have a big company, you're trying to like help various different teams be able to write and maintain their own pipelines in the same way and kind of have some kind of shared patterns across the company. Like it's a jungle out there.
Yeah. So as we go from build, deploy, run, and test, either on our local machines or on some runner somewhere in GitHub or GitLab,
yeah,
how is the workflow, the developer workflow changed over time, and then how do you see it? How do you see it being solved?
Mm-hmm. Yeah. So I think a few things have changed. Like, and I think maybe the clearest way to look at it is like, what are the sort of the repeated steps? Like when you deliver a piece of software, you start writing it, you debug it, you write some tests, you run the tests, you open a pull request, something fails in CI, you fix what goes wrong in CI, then you get code review, you address PR comments, fix those, and then it gets merged, and then it gets deployed. So what's happened is like some of the parts of this, like some of these parts haven't regressed that much. I mean, like, writing code is still writing code. But being able to, first of all, see the full implications of what you've just written is not as easy as it used to be. You used to be able to just like, you write some code, like, I wonder if it works now. I wonder what happens if I do this. Right now, you can sort of see the effects on whatever services you've got running locally, but like to see the full implications, like sometimes like it breaks in staging, even if it didn't break any tests because you didn't have coverage for that. And then like you can't reproduce that stuff without going through the pipeline every time, because like what if it's like the sort of the order service is now getting 500 errors from the billing service because it's like the field has an underscore in it, but it should like have camel case or whatever.
Mm-hmm.
And so you try to fix it, and like, how do you know if it works, your fix? You can't do it locally. You have to commit and you push to your PR, and your PR reruns, and then like this whole giant pipeline starts up again. And like if you're lucky, your DevOps engineer has like built in caching to that thing laboriously by hand. But usually like you're rerunning a bunch of slow steps again and again and again. And then like if it's 3 or 4 times you have to try it, that's like half an hour a pop. And that's like, it starts to really add up. And so in terms of like the kinds of like how much of the behavior of the production system are you able to reproduce locally or sort of in the inner loop? I mean, locally, it doesn't have to be locally. You can also be, if you have a remote development environment, but it kind of, you're synchronizing code or it's kind of live updating in any kind of way. I just mean like your personal sandbox that responds to your changes in seconds, not minutes.
Yeah.
If you can reproduce things there and rerun tests there, I think what's been changing is that like there's more and more things that we can't repro, more and more behaviors and more tests that we cannot reproduce without going through CI. So CI is so we're like we're getting into the sort of the commit, push, wait, doom loop. Not always. Like a lot of the time, you're working on functionality that is unit testable. You're like changing some library function, and then you're fine. But like, there's this thing in like in sort of project management around the engineering. It's like I think it was something like engineers are great at like estimating the expected time it takes to do a task, but not like the time to ship a project is kind of dominated by the feature that went most over schedule. And we're really bad at estimating that. So it's like that one thing that ended up being way more time consuming than the other things. And that's what derails everything. And this is like really where, those things start to blow up. And then, you're writing some feature that seems pretty innocuous, but then it ended up actually breaking something that required you to get into the CI doom loop. And it took hours and hours and hours and really wore you down, and it slows you down. And like, it's not your fault. Like it's just like you're talking to something, you're sort of, your conversation partner is too slow. But like, I'm not saying it's everywhere, but it is kind of throwing a spanner in the works. And I think it's like, to be honest, like it's making programming seem like a less fun career for a lot of us than it we thought it would be.
Hmm.
You know, you get into coding and it's like, I'll sit down at the keyboard and I'll make magical things. I'll create these magical things and it'll just be really fast and I'll, you know, make things happen. But like, then you're just turning this crank a lot of the time.
Hmm.
And there's never really time to sharpen the saw because you're so busy sawing the trees. And so I think we have to kind of level up our tools so that we are able to reproduce more behavior locally or in our personal dev environment. So basically level the power level up, sort of level the playing field between dev and CI, and sort of be able to reproduce, if not everything, then like most things that happens in CI in dev. But like, yeah, so that's kind of our take on it. But like, there are like there are sort of a few approaches floating around in the space right now. Like some companies prefer sort of a more sort of platform engineering approach where you basically create an internal developer platform type thing where you point and click, you can sort of have you have a service catalog, you pick components and you deploy. I need a Redis instance and I need a database, and you create an environment, and so you can test your changes from a branch and sort of poke at things. And it's not as fast as what I'm describing, but it is simple to use, and you're not asking the developer to like be exposed to what Kubernetes is. And I think like there's a legit difference in opinion there. Like asking people to understand Kubernetes, if you're a developer, not everybody's interested in that. And it depends on kind of the comfort level that your org has with that kind of stuff. So I guess the more you increase the realism of the development environment, the more the horns are going to poke through the cover. So I think there's still a little bit of working out going on there, but and I think that's also like what we've been seeing a lot of is that like teams are wondering, what should my deliverable be? So you have this mandate like, go ahead and make a nice internal developer platform so we can increase dev team velocity. Go figure out what people are doing out there, and like it's a jungle. There's so many different options and different ways of slicing the problem. There's like there are inner loop tools like Octero and Scaffold and Loft that focus on things like deploying an environment and doing live reloading on one service at a time. And then there are systems that come from the other side, more like Backstage and Cortex and so forth, that are more like not really trying to touch the inner loop so much, but they are helping out with the CI piece somehow. But you still need to sort of build out your own stuff. You need to have a DevOps team that's kind of building out those templates and how all that stuff fits together. And of course, Garden is a bit of an oddity in this space because it is a CLI tool that you run on your machine or run in CI, but it creates production-like environments or local environments. It runs end-to-end tests, any test suite that you have. So you can our approach is to really erase the difference between what CI and Dev could do. But I suppose
So
it asks a tiny bit more of the developer sometimes, but we're working on that.
Yeah, that's interesting. I think what I heard from what you just said was we're all trying to tighten that loop, that feedback loop of running our code and running our tests and getting that feedback to see whether what we've done actually works or could potentially work in production.
Yeah.
Or even development or staging or UAT, whatever. So I think what I kind of see out there in the world is, we either, like you said, create that that kind of portal to, transfer local dev to this portal or this code spaces environment, or this Git pod or whatever the case may be, kind of picking up your workstation and kind of migrating it. Or we're seeing just kind of these disparate pieces of putting this kind of platform together, and kind of using duct tape to get the best of both worlds, right? Because I'll in my experience, a lot of developers, they want to use all of their custom tools, and they want the desktop experience, but they also want that Titan loop and immediate feedback and kind of this consistent environment that you see with some of these other like kind of a platform as a service, I guess, or what have you.
Yeah, exactly.
So what do you think is the perfect balance there?
Yeah, so we've actually had a bit of a journey on this topic. When we started Garden, we were trying to. So one of the first sort of modules and actions are sort of how you configure the thing that you wrap your builds and your deploys and your tests around. We were trying to abstract the complexity of Kubernetes away from the developer a little bit and try to be a little bit of a Docker Compose for Kubernetes. But what we soon found was that like people need full control eventually. So right now we lean more. So our motto is automation over abstraction. And the approach that we have found to work best. So we work with companies from like Fortune 500 companies down to small startups. But what we've always found is that starting from production gives the best results. In that, like, if you take the Helm charts, the Kubernetes manifest, the Docker files that you're using in production, and you maybe modify you have a slightly different flavor for dev, maybe to include some dev tools or whatever, or maybe have slightly higher resource limits or whatever for dev. But if you're literally using your production deployables in dev and testing, first of all, you're not maintaining two versions of reality where you have like that's a classic problem. It's like you add an environment variable to a Docker Compose thing. Did you remember to add it to the Helm chart? Do you even know what Helm is? Whereas like if you're using the Helm chart in both, but you have, well, of course you need a tool as opposed to like Garden to achieve that easily, where you're able to you need a tool, do code syncing, do testing and stuff in your dev environment using the production Helm charts. First of all, you can reproduce almost anything that goes on in production in your dev environment, and also the DevOps engineer and the SRE, like you're only maintaining. You have this is the way it is deployed and built, and then we sprinkle some dev automation and testing automation on the outside, but there's only one canonical definition of how things are done. And so I have yet to see a successful platform as a service offering on top of Kubernetes. There are, of course, interesting things going on in the space like Fly.io, but that's, of course, a very different take. Very cool, though, by the way. We're big fans of Fly over Garden. And Kubernetes is a bit full on for a lot of companies. There's like I saw this cartoon, like, I don't know if you've seen this meme where the guy is eating cereal with a giant spoon.
Yeah.
And the spoon's kind of too big for the bowl. That's often Kubernetes for small companies. But yeah. So I mean, for me, it always comes back to like these repeated things that you're doing again and again as you ship software. Like, how are we talking seconds or are we talking minutes when you're reproducing things that go wrong in CI? Are we talking seconds or are we talking minutes when you're rerunning test suites? Like, how much unneeded work are we repeating? And like, versus like how much complexity are we introducing to the developer? That's of course on the tool to sort of not maybe hide it, but like at least make the machine not be up in your face all the time. But I do think we have to get a little bit more ambitious about how much can we speed these things up. I mean, if things are taking if you take things down from 10 minutes to 5 minutes, that's a big improvement. But you're still drifting off. And there's this guy on the thread about like the problem with slow tools. By the way, I wouldn't be commenting on this Hacker News article if CI pipelines weren't so slow. And so I really do think that like we need to fundamentally re-examine a little bit what we are able to do without. We've been leaning on CI pipelines as a crutch far too long, and it's not their fault, but we just need to, again, whether it's Garden or something else. I mean, another tool that's a little bit like us in philosophy is Dagger. which is sort of way to sort of have portable CI pipelines that could be run on your machine, on your local machine, and in CI. Although they are not focused on the sort of the code syncing and the development stuff, but they do give you portable CI. And of course, like as you know, like developers are very I'm one of these people, very particular about their dev environments. Like what I'm doing locally is like that's such a big part of my professional life. It's like it's like your personal dev environment is like your apartment. Like it's very personal.
Yeah.
What color the walls are, like what furniture there is, it's my things. But then CI is like the bus or the train. It doesn't have to be mine. It just has to sort of work, and it's a little bit of a compromise in design. And I'll accept all kinds of things in CI so long as they're like reasonably, fast. But I think you're going to have a hard time mandating a development environment to people. You can offer it to them as an option, but that's why, like, what we commonly see with Garden, with our users and with our customers, is like some developers love using Garden all the time, like code syncing. They're running Garden with sync mode, and they just use Garden all day, every day. Whereas others prefer to just do local development, but then they kind of reach for Garden when they're reproing things that go wrong in CI. So it sort of depends, but I guess CI for complex projects is where we see the biggest impact of Garden.
Yeah, let's talk about that a little bit. I think it's interesting for developers, engineers, managers to have this kind of syncing process, or like you said, while someone's running those tests locally and going to check in their code, they don't crash with another person's work, and as you scale, that problem gets worse and worse, right? So
yeah.
What are the, I guess, for teams, I'd be interested to hear maybe some experiences, or what you're seeing the most benefit there is.
For sure. So what you're getting at there is one of the common headaches that people are faced with, which is you have a shared environment. There is staging. So one of our users had this problem before they came to us, which was they had two problems. They had one staging environment, and they would post in Slack, hey everybody, can I have staging for a bit because I need to test my branch. No, like I'm using it right now, but I'll ping you in a few minutes when it's available. So there was like this queue in front of staging. And secondly, they had like a Docker Compose local dev environment, and it was getting really heavy. And they had like high-end MacBook Pros, but you'd start Docker Compose, it would take 20 minutes to spin up, and you would kind of, fingers crossed, hoping it doesn't crash because they need to start over again. So the sort of the local environment was also starting to groan a little bit under the weight. And what they did is, so what do you need to get what you call ephemeral environments? Ephemeral environments means like a copy of the system that's like, has a different URL, or it's sort of dynamic. You have some kind of dynamic configuration in there so that you can have as many of those side by side as you need to. They have their own databases and stuff, and then you can just like tear them down when you're done with them. So the thing that's standing in the way of that is usually two things. So like either you've kind of handcrafted your staging environment, you just like spun things up. Maybe if you have VMs and stuff in the mix, that's classic. Because like nobody is necessarily going to help you to be able to spin up a completely correct version of your system with one script. I mean, if you have that, and if you're able to parameterize that, like for example, you maybe need to have like just simple things like you need to have like the pull request number or the build number in the URL somewhere, so that it doesn't so you're routed to the right thing. And just like for one reason or another, people don't have the automation in place to make that easy. So that's one thing. So ephemeral preview environments. So that's actually usually where people start with Garden, is they start by deploying. Then it's testing. So especially when you have a large pipeline, maybe it's end-to-end test, there's a lot of builds in there, you tend to have a lot of repeated steps. And the reason for that is that caching is scary. Like if you get it wrong, if you cache something when it should have not been cached, you maybe get bad code into production. So a lot of the times, especially when you have complicated pipelines, you default to, you know what, let's just take it from the top. Let's be conservative. Let's and like the thing about caching logic, it's like, I don't know if you've ever written a parser by hand. It's like this state machine of things. And if you change the grammar a little bit, the whole thing has to be kind of reworked. And it's like, what if I want to make a change somewhere else? Does that invalidate like who knows how the whole thing works? So it's just like there's a lot of repeated, the combination of slow tools with steps getting repeated unnecessarily is a killer. And this is why I'm not joking. Like we've often heard of end-to-end test pipelines going down from like an hour to 2.5 minutes with Garden. And that's not because we're doing anything super, not because we're making anything faster. It's just because we're able to skip unnecessary steps. And again, that just goes to show how, we need more automation, I guess. And I mean, our approach to this is Garden does builds, it does deploys, it does tests, it does scripts in between, it does the whole thing, and it versions everything based on the files that go into the builds and stuff. So we know we have this kind of dependency of where versioning, so we are able to know when it's safe to skip, and that's the TLDR of it. So it makes caching safe. So it's that speeding up pipelines, getting ephemeral environments, and then it's also production-like development environments and being able to reproduce things that go wrong in CI without triggering the pipeline as well. So it's like companies are spending where the developers are spending a lot of time waiting for CI, which is common. I mean, we commissioned the study in 2020. I think maybe I can post it somewhere. Where we had this firm interview like 500 companies of varying shapes and sizes, and like people are only spending 14 or 20% of their time writing code. Obviously, we shouldn't be writing code all the time, but what struck me there is like a lot of time is being spent waiting for builds, waiting for pipelines, and working on and maintaining internal tooling. And yeah,
it's very attractive building these ephemeral environments. I think that is a huge issue that I see a lot, is being afraid. Being afraid to kind of truly treat your production as dev, which
exactly.
only some dare to do. And then also it's like you said, being able to parameterize everything to where your production environment looks exactly like your dev environment or staging environment. So that is really interesting. And I could see the immediate benefit to that. You did say you had a demo for us. Do you want to show off some of those capabilities or have anything for us there?
Let me see. I will do that. Let's just promise would be nice if the demo gods don't favor me today. Let me see. Entire screen. I think this. Oh wait, there it is. There we go. Okay. Does this work?
Yep, we can see your screen.
Yeah, the screen's just a little bit. So like all right. So what we've got here, I'm actually going to show you also another version of this. So I'm looking at an example project here. It's an application for voting for cats or dogs. It's an old classic Docker Compose project that we've adapted for Garden. Just going to start Garden here in this project here. There we go. Open the website. Okay, so I wanted to show you the graph. Yeah, there we go. So
if you could zoom in a little bit too, that'd be nice.
I can zoom in a little bit. Yes. So what we're looking at here is the stack graph, and so what we can see here is that these are all the steps you would need to fully deploy, build, and test your stack. So you start here at the left. There's the builds before you test, builds before you deploy, and then there's these run steps to, for example, here you deploy a containerized Postgres, and then you seed it with a schema and test data. Here's some other runs that are kind of basically wrappers around scripts as you run sometimes, because sometimes you do things like generate a database migration or clean a database or whatever. And then here at the end, you deploy the services, and then there's end-to-end tests and so forth. So what again? Oops. Still getting the hang of this. There we go. Okay, so what this shows is that like we've represented this. So this looks a lot like a CI pipeline in a lot of ways. But the difference is that like, so what Garden is based around is that like most pipelines kind of boil down into build, deploy, and test steps, and then run this kind of a catch-all for like scripts that glue things in between. And there are sort of in Garden built-in semantics for builds. Like for example, we can do building in the cluster using BuildKit or Kaneko, checking the container registry for build statuses. So there's a lot of kind of batteries included stuff. There's a lot of batteries included stuff around the semantics of builds and deploys and tests and so forth. And so what you basically do is like, so here's a Helm chart on the right, which is kind of what you would be deploying in production, various values here. And all we're doing in Garden is we're putting like some variables in here. This is kind of would be critical for the ephemeral environment case, where you have sort of variables in the project level. Let me see if I find this here on the project. There we go. So we have different environments, local and testing. You can imagine having a preview environment. And then you can have different values for these, and these then get propagated throughout the stack. And all we're doing here really is we're just like, these are a bunch of like all the values that the Helm chart takes, and we're just like feeding in like, so here's a container build next to the Docker file. So you just kind of make Garden aware like there's a Docker file in this directory. We're also going to use this Docker file for unit tests in CI and also in local dev. And then we're going to feed the build into the, if we change the source code for the service, then that's going to update the build, which is going to update the deployment. Anyway, so it all kind of fits together. And what's going on under the hood is Garden is calling Helm, it's calling the Kubernetes API. And it basically like you point it at a cluster of your choice. So let me just move this up here. So in local Kubernetes, I actually don't have Docker or Kubernetes running on my laptop, just for show, but it works just the same on Minikube, Docker Desktop, what have you. But what we recommend in general, if you're using Kubernetes in production, is to use remote environments. And then we will do building in the cluster. We synchronize the sources into the cluster. We do building there using BuildKit. We push to the container registry. And the nice thing about that is like then you're using the container registry as a shared layer cache for the entire dev team, which is quite nice. Anyway, so if I go here into the maybe I'll actually just do it in the terminal. I think it might be the screen is quite small.
And by remote you mean it could be anywhere, right?
Yeah, so it's just like any Kubernetes cluster. It could be, one of the big cloud providers, Azure, GK,
AKS, yeah,
or really like basically, or if it's on-prem, just any, it basically just piggybacks off whatever you have in your kubeconfig.
Okay.
So that's how it works. So
cool.
Let me just start the dev environment again. So now, okay, I'm just gonna wait for this to load. So I'm going to deploy all of the services, and I'm going to put the API and the vote service into sync mode to start code synchronization. Okay, I'm going to wait for this to complete. See vote. There we go. Yeah. So what I've essentially done is like all of the steps that I would usually kind of map out in CI with steps. They're just like these kind of declarations. You have builds, you have deploys, you have tests, and you have runs. And importantly, there are like these dependencies here. So before you deploy this service, you need the API to be up and the result to be up, result service to be up. Result service depends on Redis, and that's how the graph gets put together. So in some ways, it's a little bit like a makefile where you just like you declare dependency for the steps. But then what I'm able to do is like I'm able to for example here, if I run Garden test, test, it's going to run all the test suites. But you see that they all count as already passed because I'd already actually run the test of these versions at these source code versions. So what's going into that is that like we're calculating the Git versions of all the files that go into all the builds, the fully resolved configuration for the tests, like all the container environment variables, the host names, all that stuff goes in there. We hash it together, and based on that, Garden is able to figure out like how we run this before. And so that means that like I'm already like I'm skipping a bunch of things. Sorry, go on. Did you have a question there?
No, I understand what you're saying. That makes a lot of sense.
So I just wanted to show you something real quick. So like if I break this endpoint here, so here we have an integration test. It posts a vote to the API. Let me just actually, maybe I'll show you the front end real quick, just so we know what we're looking at. There's flowers versus trees. Post this message here. Maybe if I go to the logs here, I'm just put that over there and shrink this here. And let me see all the things. And I'll put some votes in. Of course, this is not a reliable election system because you can vote several times, but you see the the API gets the vote and then the votes come back. So you're able to sort of follow along with the logs in the different parts of the stack. You can also do this, by the way, in the terminal. But anyway, so the API gets these votes from the front end, and if you should get a 200 status back if you post a valid vote. So that's the test. So I'm going to go in there, and so I can either run these tests via the Garden test command, but I can also just like I can get a shell into the running service, this end-to-end runner here, and I can run the test from there as well. So what was it, like npm run integ, I think. Oh yeah, end-to-end. This is the suite as well. So like if I'm doing this in the inner loop, I would usually want to do this. Now, if I break something here, for example, if I make this into put, now it's broken. You're not going to get a 200 status. It's not going to respond at all. So typically, without something like Garden, how would I go about reproing this? Like, so this is going to not break my unit test. So I'm not going to see any problems before I push. It's going to break in CI. And what I would usually do is like you try to fix it, you push again, you wait for the pipeline, doesn't work. You try to fix it again. You run the pipeline, and you sort of eventually you're able to repro it and fix it. But first of all, you have to go through CI. Second of all, your CI is probably, unless you have amazing DevOps engineers, repeating a lot of steps. Whereas here, I could just run the end-to-end test here, and I see the failing test feedback immediately. You're seeing it seconds.
Wow.
It's obviously this is like a very simplified experience, but like literally when we're developing our cloud product, this is what we do. We have code syncing going on, and we're just running integration end-to-end test inside the service with code syncing. So we have a unit testing like experience. And if I go ahead and if I fix this now, let me see, delete, wrong, this, okay, still doesn't work. Put, no, was it post, was it? Yeah.
Post, yeah.
And there it is. And imagine like something goes wrong in CI, right? Imagine I've seen this there. All I gotta do is I start my development environment. All I did here is like I have the repo locally. I deploy and I turn code syncing on in the services that where I'm going to be running the tests and whatever. And then I can just rapidly debug this. And so by the time that I push changes to my branch, I'm like 99% sure that my CI is going to pass. And at the same time, I also obviously like I think this part is maybe the let me if I can show you the colors. I can change the colors as well on the front end. Let me see. See, color went later. Wow. I change this back. But this is like this is something that you're maybe used to seeing from like front end frameworks or stuff. But I think the interesting part comes in that like so what do we just see here? We're seeing a developer experience that's very much like local development for integration tests and end-to-end tests. And so it takes a little bit of setting up. It's not that complicated. But what I'm essentially doing here is like I'm using my production Helm charts, my Docker files. I'm adding a little bit of code syncing. So let me just show you how the code syncing works. So you see here, it's like I want you to take the deployment called vote, and I want you to take the sources from here, from this build, and I want you to sync them into this path in this container that's deployed by the Helm chart, and I want it to be a two-way sync. And then it just happens in the background, and then it's kind of up to you how you do the actual live reloading. And then, okay, so how does this work in CI? Well, all you got to do is like garden deploy. Garden deploy creates an environment. That would be like a preview environment. So like that is env. To run all of your tests, it would be garden test. And this is like, obviously it's doing a lot of stuff, but this is a little bit like, you do Terraform apply and it does a bunch of things, because you've already kind of, so the essential thing is the structure of how the thing is done is represented in a portable way. So the garden config lives with the repo. You can, by the way, easily bring this together from multiple repos. Garden can sort of give you exactly the same developer experience that I showed you here with multiple repos. Yeah, so like our take is that portability is the key. I think portability is why Terraform is so great, why Pulumi are so great. And our take, I mean, obviously I'm biased. Our take is that like it's time that we do for dev automation what Terraform did for infrastructure. So the reason we're able to do this caching and do all this fancy stuff is because Garden is it's not opinionated, but it has built-in concepts of what is a build, what is a test, what is a deploy. Whereas a CI system, it's kind of out of scope for a CI system to get into that kind of stuff. But like Garden doesn't replace your CI system, by the way. You would basically, people most commonly call Garden from inside GitHub Actions or Buildcat or whatever. It's just that like over time, what we see is that the pipeline definition shrinks down. Because most of this kind of graph structure that people are kind of laboriously writing out by hand right now, it's now inside the stack graph, So instead of having pipelines, you just have a graph and you ask the graph to do your things.
Creates that efficiency that is much needed to kind of streamline what pipelines are meant to do, right? And so it gets you away from, like you said before, having to rerun the pipeline just to get your code to pass, to get your test to pass and release to production. I think this simplifies that, but also like you were just execing into a pod, getting a shell to the container. I think offers a lot of flexibility as well. So it's not it's not something that will limit you. I think that's what a lot of developers get afraid of, right? Is that you're introducing this tool, it's going to be the replacement for all the other tools, and now it becomes this kind of mysterious kind of single pane of glass. And
exactly. And so of course the thing that people get scared of and think that I often, when I see like, here's this giant totalizing framework that's going to be the front end to all of my stuff, and it better think of everything. Whereas like, which is why exactly what you're saying is like, it's good to have the reassurance that you do have the escape hatches if you need them. But of course, like I prefer to shell into the pod. There are also simpler ways to rerun tests in Garden where you don't have to actually know that you can wrap these things in nicer ways for the developers. But I like to see what I'm doing myself. But
that's great. It's great to have that flexibility. So you have a new version. It's called Bonsai. Can you describe the difference between using actions instead of modules?
Right. Yeah. So this is a little bit like Garden history. So like back in the day, you could say like Garden's original design was very much sort of Docker Compose inspired, where you have like, here's some code and here are the things you do with that code, and all of those things live in a module. So there's a build, and then you maybe deploy that thing, and then you test that thing, and then you have scripts that run inside of that container. So that we thought it would make sense to kind of organize all of the things that are done with a given build. But then as Garden started getting used more in CI, because the original use case for Garden was not really CI. It was really just like the development environments. But then what we found is that like there were certain places where that got a little bit awkward to have to always like, what if you just have a one-off script, or what if you have an end-to-end test runner? You don't really want a module around that. You just want to write like, here's a step. Can I just have steps, please? So that's the TLDR of it is like we've moved towards more of like it's still the same ideas. It's just that we've gotten rid of this sort of module hierarchy, and it's a way to write your configuration that's a lot more familiar to people coming from traditional CI. I mean, you're still writing down steps. They have that dependencies on other steps. I guess the main difference is these built-in graph semantics and sort of the batteries included. You know, you have Helm deploys, you have Kubernetes deploys, and so you can sort of be a bit more concise like that, I suppose. But yeah, so it's really us like breaking things down and simplifying them a little bit and making them more easily composable. I mean, you go out there and then you come up with some initial design, then you work with companies that have all kinds of sizes of stacks. I mean, the fundamental design of Garden has held up quite well, but this is one big thing that we felt that we needed to do to make Garden more easy to understand. But I guess that's for all of you newcomers to Garden. That's the path, I suppose. But
yeah, and that makes sense. Again, to follow the individual pieces that you can put together yourself, right? Versus having to have this huge modular system. So
exactly,
that seems like the right way to go. And so so yeah, this is all great. I think this will help a lot of developers streamline a lot of workflows, save a lot of time, and releasing apps to production and services. So I appreciate you taking us through that, and looking forward to seeing your company grow and the tool continue to develop. So
thanks.
Yeah, thank you.
And just like regardless of whether it's Garden or some other tool that wins out, I think we owe ourselves something more fun than the way most of us are doing things these days. And I hope as an industry we succeed in making programming a bit more magical.
Yeah, and as we shift left, as all of us are doing, we don't have a choice but to shift left, it seems, in terms of rolling our own code. We're gonna have a need for these solutions more and more, I feel. So there are a lot of tools out there, like Backstage, like Cortex, and we'll continue to see that shift towards trying to kind of coalesce all these tools into a kind of a perfect world of developer workflow. So we'll see how it goes. But thanks Thor for joining and explaining all that. I really appreciate it.
Thanks for bringing me on.
And thanks for all of you who are still sticking around. Appreciate you joining. And if you are catching this later on, please do check out garden.io and also check out KubeSkills. We're a community that's learning about containers and Kubernetes, and we'd love to have you and start a discussion on learning about some of these tools that to build some of your platforms. So with that, I will let you go. Thanks again, Thor, and everyone have a good day. Bye-bye.